All right, Unit 8, Day 2. We're going to talk about everybody's favorite stuff here. Still working with square roots and all that, but we're going to work with complex and imaginary numbers. Okay? So, remember, we're in the real numbers, everything we've dealt with so far, we're not allowed to take the square root of negative numbers, right? When we're in the real numbers. If you try and type in, like in the calculator, if you try to type in the square root of -2, it's going to say non-real answer, right? It's going to give you an error because it doesn't work in the real numbers. So what we do is we switch into the complex numbers, right? Somebody decided they wanted to work with these negative radicands. So they created an entire new system of numbers based on this one fact right here, okay? That the square root of -1 is equal to I, okay? So when we go to simplify square roots that have a negative radicand, we're going to do the exact same thing we've been working with, right? It's the exact same thing we did last time. So we're looking at -25. What we're going to do is we're going to split it into -1 because it's negative, and then we're going to say 25 is actually itself a perfect square, right? So if we take the square root of these things, we have that 3 out front, and then based on that whole, the whole thing that complex numbers are based on, the square root of -1 is I, and then the square root of 25 is 5. So that came from that came from that. So when we multiply this together, this would just be 15I. That's all we're working with, okay? Same thing happens here. 72, -72, we're going to say is -1. And then 72 is not a perfect square. So 72 is 36 times 2. So if we take the square root here, that would give us I times 6 times square root of 2. So that would be 6I square root of 2, right? So it's the same thing, it's just when you see the negative, that means an I comes out. Other than that, it's the same thing of exactly what we've been working with, okay? Same thing here, -54, we're gonna go, that's -1. 54 is not a perfect square, but 9 goes in there 6 times, right? So now, square root of -1 is I. Square root of 9 is 3. And then we've got square root of 6. And then we've got that -1/3 hanging out front. So when we multiply these things, -1 times 3, or sorry, -1/3 times 3 is -1 times I square root of 6, which is just -I square root of 6, right? So that's how we're working with these, okay? It's exactly what we've been doing. Again, it's just if you see negative under there, I comes out. That's it, okay? Now, working with powers of I, the nice thing about these is there's a pattern, and that pattern repeats every fourth power, okay? So I to the first power is just I to the second power is -1. I to the third power is going to come out to be -I, and I to the fourth power is going to come out to be +1, okay? And then I to the fifth, it would start back over 6, 7, 8. It would start back over at 9, 10, 11, 12, start back over at 13, so on, okay? So to simplify these powers of I, what we do is we are going to divide the power by 4, okay? And then the remainder is going to be what power of I is left. So if we're dividing by 4, okay, we have a remainder of 1. Right, that's going to be 0.25 as a remainder if we're dividing by 4. Here, if we have a remainder of 2, That's going to be 0.5. Remainder 3. 0.75. And then in this case, if it goes in evenly, it's going to have a remainder of 0. So it means it's going to go in evenly. Okay? So 0.0, right? So if we're going to work with these powers of I, the way we do this is we take our power, we divide it by 4. So 15 divided by 4, that is 3.75. Okay? So 0.75 is remainder 3. So what we would have left would be I to the third, which is negative I, according to our pattern up top. Okay? Then we do the same thing here, I to the ninth. We take our power divided by 4. That's 2.25, right? 0.25 is remainder 1. So what we'd have left is I to the first, which is just I. Okay? Same thing here. We're going to take 22 divided by 4 is going to be 5.5. 0.5 is remainder 2. So what we'd have left is I squared, which I squared is negative 1. Okay? And then last one of this, 16 divided by 4 is 4.0, right? Remainder 0. Right? That means that it's I to the fourth, which is 1. Okay? So all we're doing is dividing it by 4, the power by 4, and then checking what our remainder is. Okay? Going from there. Now, working with these complex numbers, okay, you can add, subtract, multiply these complex numbers just like we do anything else, right? So when we work with these complex numbers, they're usually written in the form a plus bi, okay? Where, in this case, when we write these things, they have a real part and an imaginary part. So the real part is the part that doesn't have the I. The imaginary part is the part that has the I, right? So in these, like in this guy, the 2 is the real part, and the 5i is the imaginary part because it has the I. Pretty easy, right? So we typically write the real part before we write the imaginary part, okay? But when we go to add and subtract these things, what we do is we add or subtract the real parts, and then we add or subtract the imaginary parts, okay? Only thing you got to make sure we're careful of is if you're subtracting, you must distribute the negative sign before you combine anything. Okay? Distribute the negative if we're subtracting. Okay? So, in number 8, we're adding, so we're good to go. We can just combine. So, in this case, we're going to take 5 plus 4 is 9. Then we're going to take 6i plus 7i is 13i. Okay? So, that's all we're doing. Basically, all we're doing here is we're going to treat the i's like x's, right? We're going to do everything we normally would. We're just going to treat the i's like an x. That's the only difference, okay? So in this, we're subtracting here, so we've got to distribute this negative sign. So minus 6 minus 2i. Now we can combine stuff. So negative 5 minus 6 is negative 11. 2i minus 2i would be plus 0i, which 0i is just 0, so this just comes out to be negative 11. Okay? And then last one, in this case, right, we've got some subtraction here, so we're going to distribute, and then addition, so nothing to distribute there. So we'd have 4i minus 3 plus 2i plus 5 minus 8i, right? And now we combine. Real parts, so negative 3 plus 5 is 2. Imaginary parts, 4i plus 2i is 6i, minus 8i is negative 2i. And then that's what we got, okay? So that's how we're doing with that. Now multiplying, again, we're gonna do the same stuff. All the same rules applies in real numbers. The only difference is if we get an I squared, we're gonna replace I squared with negative 1, okay? That's the only difference, because remember up here we said I squared is negative 1, right? We found that up here. So we're going to replace I squared with negative 1 to simplify things, all right? But we multiply all those things the same way we do in the real numbers. So when we go to multiply 4i times 5, we're just going to take 4 times 5 and say that that's 20i. Okay, still just treating the i's like an x. Here, negative 3i times 2i, negative 3 times 2 is negative 6, and then I times I is I squared, okay? So this is where the new thing comes in, where we're going to replace I squared with negative 1. So we have negative 6 times negative 1 when we replace that I squared with negative 1. So this comes out to be positive 6. That's it. Okay? Get to 13, right? Normal stuff, right? We would just have to distribute here. So we take negative 5i times 7, so that'd be negative 35i. And then negative 5i times negative 1i squared would be positive 5i squared, right? And then same thing, we have an I squared. So replace I squared with negative 1. So we've got negative 35i plus 5 times negative 1. And notice, again, we don't replace I with negative 1. It's just I squared, right? So that I stays put. So now we've got negative 35i, and that would become minus 5. And usually we write the real part first, so if we rewrite this, it'd be negative 5 minus 35i. If we write the real part first, then the imaginary part, okay? And then last one in here, again, we treat it just like we would if those i's were x's. So to multiply these, we're gonna FOIL. So first, outer, inner, last. So if we go through here, right? And we take the first terms, negative 3 times 2 is negative 6. The outer terms, negative 3 times negative 7i is positive 21i. Then the inner terms, 4i times 2 is 8i. And then the last terms, 4i times negative 7i, be negative 28i squared. Okay? So now if we look, we've got like terms here in the middle we can combine. So 21i plus 8i would be 29i minus 28i squared. And then we have an I squared here. So we're going to replace I squared with negative 1. Right? So we would have negative 6 plus 29i minus 28 times negative 1. So negative 6 plus 29i, that would turn to plus 28. And then we have like terms here. We can combine negative 6 plus 28 is 22 plus 29i. Okay? And then that's that. Right? So that's working with complex numbers. So try out that homework and then let us know if you have any questions.